Assalamualaikum warahmatullahi wabarakatuh. My name is Najah Afrika and I will explain to you about spectroscopy. Spectroscopy refers to a wide range of techniques that use radiation. The basic idea behind all spectroscopy techniques is to shine a beam of electromagnetic radiation onto a sample and watch how it reacts to it. Typically, the response is measured as a function of radiation wavelength. The spectrum is a plot of the response as a function of wavelength. So, FM spectroscopy is a sensitive high-resolution absorption technique. Frequency modulation alters the frequency of light rapidly around the central carrier frequency. Changes in this frequency component, which can be isolated electronically, indicate absorption. The resulting signal is relatively insensitive to changes in the laser intensity and thus has much higher signal-to-noise as in the much less noisy FM radio.
Parts of FM spectroscopy. A laser is a device that uses optical amplification based on the stimulated emission of photons to produce light. The most ideal laser for FM spectroscopy is the tunable diode laser due to its narrow line widths, large tuning ranges, and its outputs which are stable. Oscillator operates on the idea of oscillation, which is the periodic fluctuation of two items based on energy changes. Modulator is where the information is transmitted by an electronic wave through the process of called modulation. Sample cell is where the modulated signal from the modulator is applied to the sample cell for the measurement of absorption of atomic or molecular vapor present in the beam. Detector or demodulator. Demodulator extracts the information content from a modulated carrier wave. Then we have slope detector. Slope detector is a tank circuit that is set to a frequency that is either slightly above or below the FM carrier frequency. Ratio detector is the instantaneous frequency variation of the FM input signal were transformed into immediate amplitude variation by the radio detector. Gated beam detector, or known as the quadrature detector, it detects and amplifies the received signal using a gated beam tube. The output voltage is 0 when the input frequency is equals to the center frequency. The output voltage becomes positive when the input voltage exceeds the center frequency, and it becomes negative when the input frequency is below the center frequency.
Design of frequency modulation spectroscopy. Frequency modulation spectroscopy is optical heterogeneous system capable of sensitivity and rapid detection of absorption and dispersion methods. This spectroscopy is used to detect the trace gas, to measure the moisture activity, and to inspect the peripheral barrier. So this is the example of design of frequency modulation spectroscopy. It's a single frequency laser, phase modulator, sample, pulse detector, phase adjuster, RF mixer, and RF oscillator.
Application of frequency modulation spectroscopy. First, a headspace analysis tool, which to designed to be administered intravenously or by injection. Second, the measurement moisture activity in pharmaceutical samples, which to avoid all sample handling issue during the measurement. A non-destructive technology, the laser frequency is tuned to match an internal absorption frequency of target molecule. Fourth, vacuum seal integrity testing of clean physics biological product. The method that could accurately and quickly determine viral classes. For MR spectroscopy, allow the MRI scanner to make an image from the spectroscopy data. The radiologist will select the areas of interest during the examination.
Improvement of frequency modulation spectroscopy. Frequency modulation spectroscopy, or it called as FMS, is a powerful technique for detecting and identifying trace amount of gases and molecules. In recent years, there have been several improvements made to FMS that increase its sensitivity and resolution. For sensitivity, advances in optical spectroscopy rely on improved detection technique that reduce noise to fundamental detection limits. When properly applied, frequency modulation laser spectroscopy approaches the quantum limit for detection, having demonstrated that the double modulation FMS could achieve such sensitivity in absorption spectroscopy. It suggests race to the goal of measuring the absorption of an individual molecule. For resolution, improved by using higher modulation frequency or advanced modulation technique. One such technique is chip-off FMS, which was used by PBL in a study published in Optics Data to achieve a resolution detachment of up to a factor of 2. Another technique is cavity and stream FNS, which was used by Jones in a study published in the Journal of the Optical Society of America B to achieve a resolution and detachment of up to a factor of 10.
Equations in FM spectroscopy. These are the equations that are used in the FM spectroscopy diagram. Jn is the order of n in the Bessel function, whereas m is the modulation index. When the modulation index is lesser than 1, the frequency modulated beam can be illustrated with a strong carrier frequency with two weak sidebands. The two sidebands have same magnitude but are different in phase, resulting in no amplitude modulation since the beat nodes between the carrier and each sideband cancel out each other.